Hello and welcome to this video about inductance. We are going to talk about what mutual inductance is, transformers, and the transformer equation. Let's take a look at a little experiment that Michael Faraday set up, or at least one very similar to this, where he had a battery right here, and that was connected to a coil, and we call this the primary coil. This circuit is going to be the primary circuit. Then we also have a secondary coil. That is this coil over here. And the primary coil is, when current is running through this circuit, the primary coil is producing a magnetic field. This is an iron core. I didn't write that down. The magnetic field that is produced by this primary coil then induces a current in the secondary coil. This is just representing a meter that is measuring the voltage that is the EMF through this secondary coil. Mutual inductance is the term that we apply to the situation where we're measuring the ability of one circuit carrying a changing current to induce an EMF in a nearby circuit. And that is what is occurring here. We are basically inducing an EMF. This circuit is inducing EMF in this circuit because this is producing a magnetic field that then induces a current in this second circuit. So if we take that setup we were just looking at and we make some adjustments so that the EMF, say, this is actually reversed. We have our primary coil over here. Here's our EMF, our voltage difference over here. Here we have our secondary coil with the load. If we set it up so that the potential difference changes and it is different between the primary circuit and the secondary circuit, we have a transformer. A transformer is simply a device that changes one alternating current potential difference to a different alternating current potential difference. We can have step-up transformers where the voltage is increasing. It's going from a lower voltage to a higher voltage. Or we can have a step-down transformer where we have a higher voltage and then in the secondary circuit it's a lower voltage. We can calculate the potential difference based on the number of coils in the wire, and here is the relationship between those. If we know the potential difference in the secondary coil and we know the potential difference in the primary coil and we know the number of turns or coils in that secondary coil, we can calculate the number of turns or coils in the primary circuit, or any number of these variables. You can solve for any of those based on those relationships. We've mentioned the usefulness of transformers to power companies. They use step-up transformers when they are converting the electrical power into a high voltage to carry long distances, and then a step-down or several step-down transformers before it enters your home to the 120 volts in your home. And here's just another example of a use for a transformer in an automobile engine. This is a step-up transformer. It's increasing the potential difference across the gap in a spark plug so that we have sparking that can occur here in this little spark plug. Let's do a problem together. Let's say a transformer has 75 turns on the primary coil and 1,500 turns on the secondary coil. If the potential difference across the primary is 120 volts, what's the potential difference across the secondary? I'm just going to write down my transformer equation and plug values in. So I have 75 turns on the primary. That's N1. I have 1,500 turns on the secondary. That would be N2. The potential difference is 120 volts across the primary. That would be V1. So when I put all those numbers in, I can now solve for my potential difference across the secondary circuit, and that is going to be 2,400 volts. Keep in mind, real transformers are not perfectly efficient. Generally, they're 90 to 99% efficient, but that power loss is due to resistance in the wires themselves, and also small currents that are induced by changing magnetic fields in the iron core, and that contributes to power loss. Advanced ideas, what is self-induction? We didn't talk about that. Look that up and see what you come up with. Maybe you have other ideas, other questions. I look forward to seeing what you come up with, and we'll see you in class.